for today's home video lesson, we need to recall some information from our previous lesson. We need to recall what a quantity is, the way we've defined a quantity. That's an attribute of an object that we can measure. An attribute that can be measured is called a quantity. And we've got two types of quantities that we're going to refer to: fixed quantities and varying quantities. If the value of the quantity does not change, then we'll call the quantity a fixed quantity, and we'll say that its value is a constant. On the other hand, if the value of the quantity does change, then that quantity is called a varying quantity, and the quantity can assume more than one value. And in class we discussed examples of both fixed and varying quantities. If we look at a particular box, the volume of that box is a fixed quantity. If we're observing a certain table, the weight of that table is a fixed quantity. On the other hand, if we're measuring the height of a child, that's a varying quantity. The distance of our car from home as we're driving to work or to school, that would be a varying quantity. And the amount of money in our bank accounts would be varying. Now in mathematics, we want to represent how two or more quantities are related. We're going to say that those values covary or change together. And instead of representing the quantity's values with words, it's going to be more convenient for us to use a shorter notation. And the purpose of defining a variable is to represent all the values that a specific quantity can assume. And this is that shorter notation. Okay. So a variable is going to be a letter. Could be a Greek letter in other classes, but it's going to be a letter that is designated to represent all possible values that a quantity can assume. For example, if we want to reference the distance that a car has traveled, let's say from Los Angeles to Phoenix, we could define a variable n to represent those values, or the number of miles. And if we were writing this down, we would write maybe let n equal the distance the car has driven in miles since leaving Los Angeles and driving towards Phoenix. And recall, we're going to try to be very specific. We want to communicate with meaning. And we discussed how we might define our variable to be n, which would represent the number of miles instead of d, distance, or m. It's kind of up to the user. Okay, overnight, I want the class to look, I want each of you to respond to number 5. This is Module 2, Investigation 1, number 5 in your student workbook. And you will email me these answers or send this via Dropbox. First, you're going to view an animation of spooling out wire. This spool will originally have 48 feet of wire on it. And you're going to write down what quantities vary in this situation. Part B, you're going to write down what quantities do not vary in this situation. And then I want you to write down what constants you can identify in the situation of this wire on a spool. Then I want you to practice and define variables representing the values that the quantities can take on, the ones that vary. And I want you to write a formula to describe how the remaining length of wire varies with the amount of wire that has been cut from the spool. Let's take a quick look at that animation, though you'll need to go to www.rationalreasoning.net/flash/wire.html. Let's see if I can get to that. Yeah. And just you can make the animation move by clicking on the end of the wire of the spool. Of course, you can hide everything except the animation. And if we spool it all the way out, the length of that wire we've agreed would be 48 feet. I'll have to look back at the units. And then it's up to you if you want to graph how much wire is used. And I think it'll be interesting if you will show how much wire is remaining on the spool as well. Okay, so respond to number 5. Email me those answers by 11:59. So that's emailing all the parts of question 5, Module 2, Investigation 1 by 11:59, the day the assignment is due. Thank you.